We want to solve 25th problem of PMO, Philippine Mathematical Olympiad, Day 2 national level. Problem number 5. In this problem, we want to use an idea that useful also in IMO 2019, International Mathematical Olympiad, problem 5, second problem of day 2. Part A, useful invariant, these types of problem that, for example, say something stops. Also for BMO round to British Mathematical Olympiad. Look, BMO is all BMO and USAMO for UK and USA. These two national Olympiads are the most prestigious national Olympiads and so much useful for your CV. And as you can see, the last BMO round 2 2023 second problem again, you should use invariant. Also for SUMAC, Stanford summer camps, there are lots of invariant problems. Look, you can solve these two problems as homework number 1, homework number 2. Also, if you wanted to learn more ideas in invariant, feel free to send message to my WhatsApp number in the description and comments. Now in this video, we want to focus on this problem, fifth problem of PMO. Let's read. Sileria is very happy for the 25th year of the PMO. In his jubilation, he ends up writing a finite sequence of A's and G's on a nearby blackboard. He then performs the following operation. If he finds at least one occurrence of the string AG, he chooses one at random and replaces it with GAAA. He performs this operation repeatedly until there is no more AG string. So it changes AG, he changes AG to GAA. It's our operation. Show that for any initial sequence of A's and G's, Sileria will eventually be unable to continue doing this operation. Okay. For this problem, we can use some small example on length. Or for example on G, because we need G and the problem says we change AG, I think, to G, yes. AG to G, 3A's. So first for solving this, pause the video and try by yourself as much as you can. Then see the video part by part as hint to solve, because it's important to try by yourself. So first we have AG. Here, if you have 1G, let's solve problem. I want to use a small example. The useful idea that in all exams useful also for IMO hard, you can solve hardest problem. Fast by this idea, you should find the idea, not only the pattern. A small example on what? You can use on length. I want to use a small example on number of G's. Okay, number of G's. So if number of G equal to 0, it's obvious that you can't do anything. If number of G is equal to 1, means you have 1G. Suppose you have some number of A's before G and some number of A's after G. Suppose here you have N1, here you have N2. Look, these N2A's are useless. Why? Because you can only change AG to G, 3A's. So here in each step, if I apply this, I change, for example, this AG to G, 3A's. And so, how many A's are there here? It will be N2 plus 3. And how many A's are left here? N1 minus 1. So with each step, the number of A's before G will be decreased by 1. So how many times can we apply this operation? Can you tell me at most? Pause the video and find it by yourself in terms of Ni's. Yes, it is N1, because in each step number of A's before G, it will be decreased. Now if number of G's be equal to 2, so number of A's here, if you have, for example, N1 before first G, then after first G and before second G, number of A's equal to N2. Then after second G, number of A's equal to N3. Okay. Now, here, I want to see how many times I can apply the operation on this G. Because I have only N1 before G, so I can do it at most N1 times. Okay. For this T, at most N1 times. Now for this one. How many times I can apply for this G? I have n2 a's here. At most, how many times I can apply? And these n1 a's, it should come after this g, and each time, each of them will be 3. When we move this, for example, when we have ag, you change it to g3a. So n1 will be at most 3 n1 here plus n2. So you can apply on this g n2 plus 3 n1. So it will be okay. Now you can solve it with induction. Now I consider, for example, number of g's is at most k minus 1. Or let's consider for number of g's, suppose k we want to prove, and suppose for 1 to for 0 1 to k minus 1 we proved, we want to prove for k minus 1, I want to prove for k, also for k minus 1, and with only k minus 1 we can prove. How? I say the number of a's here is n1. Without induction also you can say the number of g's here n2, and so on. Okay. So the number of times you can apply on this g is at most n1. And so suppose, for example, you've applied on this g some number of times. For example, suppose by contradiction you are applying this operation on this sequence for infinitely many times. Because you can apply at most n1 times g, there is, for example, there is a step that after that you can't apply on first g. Okay, so first g you apply here, here, and you can apply for at most n1 times, and you can also apply on other g's. And then after that, you can say here, when you don't apply on first g, you have a sequence, okay? And you don't apply on first g anymore, we can ignore that. You have these g's, so you have some number of a's here, you have some number of a's here, g, and so on. It is for example first g, second g to kg. So it is first g that we can't apply, third g to kg. Okay, here by induction, you can say that it will he will stop. He will eventually stop after finite number of steps. Eventually stops after finite number of steps. Okay, and the problem has been proved because by induction, and we've used k minus 1 here because we have k minus 1. One way is this by induction. Another way you say, okay, on this g you can apply at most n1 times. On this g you can apply at most 3n1 plus n2. Then on next one 3 times this plus n3 and so on. So you can say the number of operations is at most what? Okay, so we've solved this problem by, we call it invariant. The problem that says something will stop. You can use these things. You can find a function or anything that you say, okay, it will be stopped after some number of steps. Or you can say we have a function that is increasing and f is integer. It is always greater than equals 0, so after some number of steps it will be decreased. There are some techniques. And the functions are what? We have 3 important functions: sum of variables a1 to ak, sum of squares of variables a1 squared to ak squared, and another one, product of variables. These 3 functions are so much important. 90% of these problems that you need to solve are this. Another one that you should pay attention for this problem, leftmost g. Leftmost, rightmost also in many problems useful. Another thing that in invariant is useful is, for example, let me tell you, something you want to say is impossible. And for example, like what? You say plus minus 1, plus minus 2, plus minus 100. It is impossible to select plus minus to reach 101. The reason is what? If you calculate all of them plus, left side will be even. If you add plus to minus, change plus to minus, it will be also be even. And this word is also, it is impossible. For example, this one is considering mod 2. And also number theory useful. And we have 3 important colorings. And in BMO round 2, British Mathematical Olympiad, in IMO useful, in US IMO useful, 3 important colorings we have. Checkerboard scheme, general form of checkerboard scheme, and columns coloring. In general form of checkerboard scheme, we have 2 types: increasing, 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 decreasing. If you want to learn important thing in colorings that are useful, in BMO round 2, let me tell you the year. 2023, 2022, 2021. One problem is related to tiles and coloring, and you can solve that problem easily with the ideas that are in previous books and problems. Okay, if you want to learn invariant, that is so much useful in SUMAC. SUMAC is Stanford summer camp, Stanford summer camp in mathematics. There are lots of problems related to invariance, more than half of the problems. It's so much good for your CV if you want to apply for Stanford summer camp or Promise. It is another prestigious summer camp. I released some hints for the solutions of the SUMAC 2022-2023, also for Promise 2022-2023. Most of the problems in Promise were same. In SUMAC, some problems, the ideas were same. Okay, if you want to learn important ideas in invariance, number theory, geometry, the important formulas, and combinatorics, as I said before, feel free to send message to my WhatsApp number in the description and comments, and try to solve these two homeworks, and you can comment your answers right below this video, or if you had questions, send message to my WhatsApp number. And please don't forget to subscribe, turn on the bell, and like the video. Thanks. See you next time. Bye.